Good morning, good afternoon, and good evening, everyone, depending upon where you have joined from. And welcome to another webinar from Data Platform Geeks. Today, our topic is on OData and .NET Core, the State of Union. And our speaker is Rainer Stropek, who is a Data Platform MVP from Austria. My name is Satya Ramesh, and I will be the host for you for next 1 hour. And Aarti Nambiar is helping me with moderation. Before we move forward, a quick word about who we are and what we do. We work for Edomner Systems, under which we have a couple of brands, SQL Maestros, under which we do a lot of advanced trainings on SQL Server data and Microsoft artificial intelligence related technologies called masterclasses. And we do have a couple of self-paced learning solutions called learning kits and hands-on labs. And we are coming up with video courses on SQL Server performance tuning and T-SQL querying and programming. And we also have a health check service for SQL Server. Peopleware India, which is our corporate training unit, and we also have a ERP product called Expand SM ERP. Our today's concentration is on Data Platform Geeks and SQL Server Geeks communities, which were founded by Amit Bansal, under which we do a lot of free in-person events and webinars all over the year. And once in a year, we do annual summit called Data Platform Summit. Here is the picture of recently concluded Data Platform Summit, which happened in the month of August in 2019 in Bangalore, wherein more than 1,000 people attended from 300 different companies, which are traveled down from 16 different countries. And across 3 days, there were more than 100 plus sessions delivered by 50 plus speakers who again traveled down from 20 different countries. So if you're working with data and artificial intelligence related technologies, so this summit is a must attend for you. And if you wish to learn more about Data Platform Summit, you can visit dps10.com, or else you can simply drop an email to contact@dps10.com. So here is a picture of DPG team and Edomner teams on the stage of Data Platform Summit 2019. So this is the DPG core team, a founder and president who is Amit Bansal, and Manohar Punna, who is a vice president. And you can see various regional mentors across various cities in India and abroad. Edomner teams across India, which are helping us to organize these events. And a big thanks to Microsoft for supporting us in our community efforts. You're a member of Data Platform Geeks. Please be a member of Data Platform Geeks. Remain as a member. You will be able to access all our free videos, labs, magazines, and host of other learning resources as well. And if you have joined today's webinar using a free, using a direct joining link, please become a member so that you will be able to access all our resources also. Beyond this webinar, if you have any questions, you can join our Facebook group and LinkedIn group. We also have a group on Telegram app, and all our webinars will be recorded, and we are going to upload our webinars under youtube.com/SQL Server Geeks channel. And we do also record videos on SQL Server performance tuning, T-SQL querying and programming, which are all available for free under youtube.com/SQL Maestros. And again, here is the Telegram link for you to join. And other than this webinar, there are lot more webinars available for free, scheduled for the entire month of January and February. And we do have an in-person event on 25th of January in Hyderabad. So here is the list, and then you can find the full list at dataplatformgeeks.com/events. All the events are for free. You can go ahead and register for all of them. So before we hand it over to the speaker, I just have a poll. Let me launch the poll. I hope the poll is visible on your screen. Please answer the poll. The question is, how familiar you are with OData? The question is, how familiar you are with OData? First option is never used. Second option is little familiar. And third option is very familiar. So I'll wait for 2 more seconds for you to answer. Just I'll wait for 1 more second. There are a few more people yet to answer the question. Yeah, looks like 56% of the audience today never used OData, and 39% of the audience are a little bit familiar, and 6% of the audience are very familiar. So with this, our poll is done, and I'll hand it over to Rainer. Rainer, over to you.
Thank you very much. I hope you can hear me.
Yes, we can hear you.
Very good. I currently cannot share the screen because you are still sharing. Could you stop sharing so that I can share my screen? Thank you very much. So please let me know if you can now see my slides in the browser.
Yes, we can see the screen.
Very good. Very good. So thank you for having me. I'm really glad to join you in this webinar and speak about the topic that is very near to my heart. It's OData and .NET Core. I'm a passionate programmer. Every day when I'm allowed to write some code is a great day. And the most of my time I spend with writing data-oriented applications. So OData is something that is really important for me. And today I would like to share a little bit of information about what the state of OData in .NET Core currently is, how you can go on with writing your own OData services to consume your services using the .NET Core platform, using the latest version of the .NET platform, the .NET Core 3.1 platform. Before we go into the details, let me quickly share the agenda and some links to the material that you can download after this webinar if you want to dive deeper into the different topics or if you want to try the samples on your own. First, let me introduce myself. I'm Rainer Stropek. I'm based in Austria in Europe. And I'm not a data platform MVP. I'm an MVP for Azure and developer technologies, and I'm also a Microsoft Regional Director. So I do a lot of work with Microsoft technologies and with Microsoft as a company. Personally, I'm really a passionate programmer. I run my own company, therefore I'm an entrepreneur. We do a lot of work in the area of cloud computing, software as a service, Azure, things like that. I'm also a teacher. I'm running a small coder dojo, a programming club for kids, and I teach at a high school for computer science. And privately, I'm a dancer. I do a lot of ballroom dancing. This is my personal hobby, my personal passion, if you want. You can reach me at this email address, at this Twitter feed that you can see here. And if you follow this link down here, rainerstropek.me, you will find a digital CV from myself. And there you also find links to my LinkedIn project, to my LinkedIn site, to my YouTube page, where you can find additional videos, and so on and so on. Down at the bottom, you see the logo of our main product. It's called Time Cockpit. I don't want to talk a lot about this product, but I wanted to mention it here because we have been offering this software as a service solution for more than 10 years now, and it is built on top of OData. So I will not just talk about theory here. I will share our insight on using OData over the last 10 years with you. So we are also using all the technology that you're going to see in this webinar. The agenda will look like this. Many of you, I heard it from the poll at the beginning of the webinar, many of you are not yet familiar with OData. So I'm going to start with talking a little bit about why OData and cover a little bit about OData fundamentals. What problems will OData solve for you? And how does it solve these problems? And then we will dive right into code. So the majority of this webinar will be walkthrough through code samples. We will run and debug some code samples, and I will try to give you a good overview how it feels like to write OData servers and clients using .NET Core. If you want to dive deeper into the material, I mentioned that before, everything is online. So you see down there, here it is. Here you see the URL to the slides that you currently are seeing on your screen. I also created, with the help of my friends at Microsoft, a small URL here. If you want to try that one, also the QR code, it will bring you to a link to the OData docs at Microsoft, and it will also bring you to a GitHub link where you can download the sample code that I'm going to show you over the course of the next few minutes. With that, enough theory, enough introduction. Let's dive right into the topic and ask the question, why? What is the problem that OData solves? To be honest, this is an approach that I always try when I see new technologies. Why should I care? Why should I take a look at it? Which kind of problems should this technology solve? I've drawn some pictures here, and I would like to walk you through these pictures. Imagine the following situation. You have on the right-hand side some kind of database. Let's say it's an Azure SQL database, for instance. And then you want to publish the content of this database through a web server. Could be an ASP.NET Core website. Imagine that you're running some customer database and you would like to allow a client, could be a mobile app on the left-hand side, to display a list of all customers. Well, that's trivial. You can do that with ASP.NET Core very easily. You can also do some RESTful design and allow people to use the URL to navigate to a specific customer, to a specific order, and so on and so on. I assume that most of you are familiar with the concept of web APIs and RESTful web APIs. But unfortunately, in real life, the world is a little bit more complex. Because in a non-trivial application, you typically have a lot of different screens where you need some data from the server side. You maybe want to display a list of customers sorted by country. Or maybe you would like to see only the new customers. Or maybe you want to see only the new customers, but now sorted by country or name and so on. And if you follow the traditional way of writing such data-oriented web APIs, you will end up writing dozens, maybe hundreds or thousands of web API controllers specific for each different screen, for each different view model that you would like to display on your website, your mobile app, or whatever your app is. Well, in my experience, things become pretty awkward now, because in real life, the front-end developers sometimes need quick response. They get some user requests. The user would like to see a specific page list sorted and filtered in a specific way. And then they go to the backend developers, and the backend developers, maybe they don't have time to create the necessary REST API. So the client developers cannot really access a new specific web API for their specific problems. And therefore, in many cases, sorting, filtering, and so on is done on the client side. At the end, you would end up with a client application which is not performing very well. Why? Because you're loading way too much data. Because you're loading all the fields of the customers. You're loading all the customers, and you're doing a lot of sorting and filtering on the client side. No, obviously, this is not optimal. So what we essentially need is we need a kind of data access protocol similar to SQL, but for the web. We need some kind of SQL for the web that works over HTTP, so you can use traditional programming concepts like HTTP clients, and it should work across firewalls and routers and things like that. It should also be platform neutral, that you can use any kind of client technology. Might be a native mobile app, might be Angular, might be React, something like this. Additionally, what we need is some kind of standardization. Why? Because we need generic clients. You don't want to build a grid, for instance, for a website from scratch by hand. If you have a standard, if we have a data access standard like SQL, you can build generic clients, a generic data grid, for instance, a generic report generator that immediately understands this data access protocol. And this is exactly where OData comes in. This is the problem that OData solves. OData is a great way to build a RESTful web API, which is very data-centric, where you do a lot of querying, and the client application needs a lot of freedom. It needs to be able to specify filtering, sorting, paging, and many other things through the URL and receives data in a standardized way. This is what OData does. Let's talk a little bit about the standard before we go into the .NET Core development part. OData is a standard, ISO IEC approved. It's an OASIS standard. And if you follow this link, let me do that here, you will get to the homepage of OData. Some tips, if you are developers, and I assume many of you are, follow the link up here and it will show you the documentation. This is not the documentation of a specific implementation of OData. This is the standard on its own. The standard is just the standardized way of formulating queries through the URL, of encoding data in JSON, for instance. It's not the implementation. If you are interested in tools and libraries, you can follow this link here, and then you will get, for many different programming languages, different libraries, and you can follow the links, and these links will lead you to the mostly GitHub projects where these libraries live. OData is designed based on the RESTful design principles. And with that, it's very different from GraphQL. So in OData, you are using the RESTful principles like using HTTP verbs to get and write data, using HTTP get to get data, using HTTP put, post, patch, delete, and so on for writing data. This is what OData looks like. In GraphQL, things look very different. Maybe you have heard from GraphQL. GraphQL is a rather new standard which fulfills similar or which solves similar problems than OData, but in a very different way. A query in GraphQL, you can see it here in the middle here, you can see such a sample query, is essentially a post request. This is not RESTful Web API. A post request would be used in OData or RESTful Web APIs to insert data. So GraphQL goes a different direction. With OData, you really end up having a RESTful Web API. OData in its core is platform agnostic, vendor neutral, although it is primarily driven by Microsoft and SAP. Let me show you what that means, primarily driven. Let me go here to the documentation and, for instance, go here to the protocol specification of the OData protocol. And if we zoom in a little and take a look at the chairs and the editors here, you will see that most people working on these specifications are from Microsoft and SAP. So you will find a lot of applications for OData in Microsoft's cloud applications, in SharePoint, in many of Microsoft's products, and also in SAP. So if you happen to work a lot with Azure and or SAP, OData might be very relevant for you. It is a powerful protocol, as you will see in a second, but to be honest, the standard on its own, it's not very valuable. Why? Because fulfilling the standard without having a powerful framework in the background that also already implements a lot of the problems that OData bring up is really hard. So on the server side, the best, and I would even say the only real good implementation is by Microsoft in .NET. So theoretically, OData is platform agnostic and vendor neutral. But in practice, if you want to build a non-trivial OData service, you will nearly always use the .NET Core or .NET platform to implement it. On the client side, OData is really completely platform agnostic. Theoretically, you can use other libraries in other programming languages. You have seen it on the OData website. But as I told you, the best and mature implementation of OData is done by Microsoft. And this is what I will show you in the rest of this webinar. So how does the OData protocol look like? Essentially, these few lines of sample code really describe OData in a very good way. The first one is, please note the $metadata at the end. You will see it here. The $metadata, with this, we can ask a server, hey server, what do you offer? For people who are familiar with SQL, you could compare that with a query to the information schema tables. So if you have a database and you would like to know what tables are available, you would probably say something like select star from information schema.tables, something like this, or use the sys schema if you want. In OData, you can use the $metadata endpoint here. It will give you some XML where you can answer the question, what tables are available? What columns are inside of these tables? What kind of joins can I do between the tables? This is what the $metadata endpoint is for, and I will show it to you in a second. The second part here, starting in line 3, shows a typical query. And I think if you take a look at it, you immediately understand how it is done. You specify the entry point, in this case, the customers table, and then you can specify things like filtering, doing things like paging with top and skip and things like that. And you can also select, so you can do projections. So it looks and feels and smells a little bit like SQL, and that is the core idea of OData. If you are familiar with SQL, the using or getting into OData is not that complicated. However, OData supports not just basic queries. By the way, I have added all the links down here, which lead you directly into the documentation of the OData protocol. So if you are interested in all the details of what $filter supports, can you do things like substring and date operations, and in the select clause, can you calculate values using mathematical operators? Yes, of course you can. Unfortunately, I only have 1 hour, so I cannot go into all the details. Please take a look at the links down here, and you will get answers to questions like that. Before we go on, I would like to focus, or I would like to point out one thing. Although I'm going to focus on reading data using OData, and to be honest, most OData services focus on reading data because this is the core strength, OData also supports manipulating data. So it is really a lot like SQL. It's not just querying, it's also inserting, updating, deleting data. You can use so-called batching with transactions and things like that. The writing part is also very powerful, but to be honest, the writing part is very similar to what you might already know from ASP.NET Core RESTful Web APIs. Therefore, I decided to focus on the querying part in this webinar and not so much on the writing part. Now let me show you some queries which are not that trivial anymore. And I will zoom in so you can really follow along easily. You see the first query, for instance, shows you that we can specify a non-trivial filter clause. In this case, I am starting with categories. You can see it here. I'm specifying a filter, but not on the categories table, but I'm joining to the products table. And there I'm doing a filter on accounting. So I say, give me all the categories where we have a product with a price greater than 5, or at least 2 products. Sorry, you can see it here. So if you think about the SQL query that you would have to write to get that, it's not trivial anymore. And you can see that this is also possible using OData. The syntax is a little bit different. So if you come from a SQL background, it will need a few days if you work a lot with OData to get familiar with this kind of queries, but you will get it, I'm absolutely sure. The second one, for instance, using a subquery, using the any clause, give me a list of orders where there is any item with a quantity greater than 100. You can see it here. Joins in general can be done with the expand clause. So if we say, give me a list of customers with their orders, including a filter, as you can see it here, we do it with the $expand clause. And this is also a very important thing. I added these examples because I want to demonstrate that OData is powerful, but not as flexible as SQL. OData doesn't give you any kind of joining like SQL, for instance, does. So with OData, you can only navigate over predefined navigation properties. This has to be implemented inside the service. You cannot join arbitrary columns in OData as you would be able to in SQL. This is by design. So don't expect OData to be equally powerful to SQL. It's very powerful, but it's not as flexible as SQL. So enough theory, let's take a look at a little bit of demos. The first demo I have opened it up here, accesses some open OData services which are available on the internet. And the first thing that I would like to show you here is the $metadata endpoint. So I click on this $metadata endpoint, and on the right-hand side, you see what we get back. If I scroll down a little bit, you will immediately see what comes back. It's an XML file. It's a so-called ADMX, the entity data model file, and it describes which entities are available. As you can see it here, we have a person. This person has a key. This person has a lot of properties with certain data types. So this is essentially the metadata endpoint I was talking about before. This schema information is really powerful, and you can not just add trivial just tables, but you can also add so-called actions and functions. You could compare that with stored procedures and stored functions and things like that. So if you go to the $metadata endpoint, you can essentially find out what the OData service offers you. You can then write a generic client that displays these things, and you could build a query builder if you want, something like this. So this is the $metadata endpoint. Now we have seen that we have some persons here, and they are available using the people endpoint. So if I simply want to get all the people in the database, I send the request /people, and you will see I get back a JSON response with some OData context information. This is essentially the metadata for the response. So with this OData context, I can find out what the data types of the columns are, which columns are available, and all the different properties of the columns that came back. And here you see the value itself. It's an array here. It's an array, and inside of this array, we see all the different people. It's not a flat structure, but it can return joined tables, in this case, a one-to-many relationship. So I get back the people, including all their addresses. So with this, OData is pretty powerful, more powerful than SQL to a certain response, keeping multiple result sets out of the question here. It's really powerful when you want to query some records with linked records, one-to-many or many-to-one relationships. Of course, you can query with a primary key. So if we want to get a certain person, Russell White in this case, we can specify the primary key like that. Or if we want to get a certain airport, we can do it like that. We will get back the San Francisco International Airport, as you can see it here. We can navigate, so we can combine filtering and navigation like that. If you go like that, for instance, just the name, then we will get back here just the name. And this one is important. Imagine that you have a client that needs to display a list of all airports, but then in a special situation, it just needs the name of a certain airport. With OData, the backend developers don't need to think of this API when they create the API. It's just available. The client has the control over what the client application just needs. It can specify the query and will get back exactly that data, filtered vertically and horizontally, that the client really needs. That's a powerful thing. I know what some of you are currently thinking. What about security? Of course, the server programmers can specify which operations are possible, and they can specify some authentication and authorization logic and things like that. That's all possible, and it will point you to the relevant documentation sections where you can read all the details about security and OData. But generally, with OData, the client is in control over what gets translated or transported from the server to the client. Here you also see a little bit more complex queries, like for instance, a contains query. I can try that one. Give me all the airports where the location field address contains San Francisco. And again, it will give me the San Francisco International Airport. We can do ordering. You can see it here. Order, NZ, something like this. And we can do paging. Please take a look at this one. This is important if you're writing a web client, for instance, and you would like to display or to offer a possibility to page through a large result set. It is also possible to use these top and skip features to implement endless scrolling, for instance. So in the back end, in the view logic, a data grid could use these web APIs to download exactly those records which are currently displayed based on a scroll bar position, for instance. For that, we can use the top and skip clauses, things like that. If you would like to try the rest of the samples, unfortunately my time here today is limited, then please use this link. It will bring you to the GitHub site where you can see exactly those queries. And I told you the service is available online, so you can try it at home using just your favorite HTTP client software, something like the REST client as I used here in Visual Studio Code, or something like Insomnia, or something like Postman, whatever you want. There are more elaborate clients if you want, and one I would like to demonstrate quickly here. It's OData. Let me go here. Yes, I will try with the online data. And let me go to a database that you're probably familiar with, Northwind OData here, for instance. This is a client that is, a generic client that is downloading the XML specification, the $metadata endpoint, and then it implements a generic query builder based on OData. That's a pretty powerful feature. You can, for instance, say, hey, give me all the order details, and I would like to see the product ID, the quantity, the price, and I would like to join to the product data, and from the product, I would like to see the product name, for instance. And then down here, you will see the URL. So the end user doesn't need to understand the details of the OData query language. The end user gets a nice little tool with which you can build the queries. I'm not saying that this tool, OData, is perfect for any application. It's just one example for what you can do by intelligently consuming the metadata, the $metadata endpoint, building generic solutions. And once we have a generic solution, we are more productive when we build different views, for instance. We do that in our own product too. We have a generic data grid, which is based on Telerik's data grid. And this data grid understands OData and our query language. And therefore, we are more productive if customers come to us and ask us for additional views, grids, reports, and things like that. I can click on Get Data, and I will see the relevant data down here, and I can also query the details of the product name. Maybe we can say not top 20, but let's say top 1000, and then it's good. So this is an example for a generic client. Of course, if you have such a query, let's quickly copy that query here. You can also use more powerful visualization tools, like for instance, Power BI. If I go to Power BI, let's start with Power BI desktop here. It will come up in a second. Give it a few more seconds. Here we are. And then we can say, get some data. And here in the data wizard, I can look for OData, and you will see that OData is supported by Power BI. And I can simply paste in the URL that I just have built with OData. Let's try whether Power BI can get some data from this OData field. OK, looks good. Let's click on Transform Data in order to flatten the product name. And here you already see, yes, we got the data. And let's add the product name too. And now we close and apply. And with this, we access our OData service using Power BI. And now we can build pretty powerful visualizations. In a second, all the data should be here. Yes, here it is. You see the fields here. Let's maybe add something like this and display the quantity, something like this. And let's make it a little bit larger. And you see, now we can use the full power of Power BI to process our data. And the important thing is that we now didn't access our database directly, but we went through the OData feed, which might include some powerful business logic, which is not that easy to implement in SQL databases, for instance. This could be our .NET Core OData service that we access here directly through Power BI. Last but not least, I would like to show you the practical application of OData, for instance, with Microsoft Graph. If you're not familiar with Microsoft Graph is a service that you can use in the cloud to access all the data which is stored, for instance, in Office 365, Azure Active Directory, and so on. Let me show you how that looks like. I have here my Office 365 account, and let me quickly sign in here. Okay, looks good. And then we, for instance, query my events for the next week. That should give me a list of events. For instance, here we see my webinar, the webinar that we are currently in, and up here you see the URL. And this is essentially OData. So what we can do is we can say, and $select equals, what do we want to select? We just want to display the subject. Let's do that. Subject. If we run this query, we will get back less data. And this is what I mean with putting the client in control. The authors of the Graph API at Microsoft, they don't know what you want, which kind of columns you want to get back from your service. But with OData, you as the client developer have the power to do projecting and querying and things like that. I could also do some filtering. For instance, I could say $filter, and let's say the subject equals, and what do we have? Maybe I copy that one. Let's see if it works. Copy it. Here it is. Close the braces, and here you see filtering works perfectly fine. And just like that, we can do paging, we can do ordering and all this stuff. This is a practical application of OData in a large-scale cloud product, which is very modern, up-to-date, written by Microsoft. Okay, enough said about the OData general protocol. Let's write some code, or let's take a look at some code. The first demo that I would like to do, these summary informations I will tell you while we are looking at the code. The first demo is a rather basic demo that I would like to do together with you. Let me quickly load up the basic demo that I have prepared for you. Give the system a second to load. It's just one page, and we will take a look at this one page, and I will walk you through the code. The first thing that I would like to point out is a NuGet package. If you would like to implement .NET Core 3.1, you see it up here, OData service, the thing you need is the NuGet package microsoft.aspnetcore.odata, and please be aware of the version 7.3.0. That one is important. It's just 14 days old, so you are getting brand new up-to-date information here. 7.3.0 is the first version of the OData NuGet package that supports .NET Core 3.1. So if you want to use .NET Core 3.1, go for OData 7.3.0, then it should work. Now let's take a look at the code. The first thing is just ASP.NET, nothing special. Let me zoom in a little bit. Here you see the customer class, nothing special. A startup class, just like ASP.NET Core. If you're not familiar with ASP.NET Core, please take a look at the documentation. I have not enough time to cover the basics, but I'm pretty sure that everybody will at least understand the code that's written here. The important thing that I would like to point out here is that one. Enable endpoint routing false. This is unfortunately currently the case with OData support for .NET Core 3.1. OData does currently not support endpoint routing. So you cannot use the full feature set of endpoint routing with ASP.NET Core 3.1. You have to disable endpoint routing. This is a feature that is not implemented in OData. It's currently worked on. It will take another few weeks or months until it is done. Currently, this is the only option that you have in order to implement OData in ASP.NET Core 3.1. Once you have disabled endpoint routing, you can add OData here in the configure services method. Next, in the configure method, you can specify details about the routing for OData. OData routing is a complex matter, and I can by no means cover everything in a 1-hour webinar. However, please follow the links in my slide deck. They will lead you to the documentation, and you can read all the different details about routing in OData. Let's quickly take a look at what I have done here in this basic example. I'm essentially allowing $select, $filter, and $top, so paging, and I allow the user to, at max, return 50 elements. The user cannot say that he wants to have 1,000 elements. This might be a security feature. Then I'm just saying that my OData feed should be available under the /OData route. So my server /OData/something will deliver my OData feed. Last but not least, we have one additional method. It's the getEDM_modal method. This getEDM_modal method drives the creation of the $metadata information. And there are 3 different ways of how you can build these metadata information. Let me quickly follow this link that I added here to the slides. Essentially, what you can do is you can read it here on the right-hand side. Currently, we are looking at the conventional modal builder, and that's the most simple way of generating metadata. You're essentially writing a bunch of C# classes and give these C# classes to the OData library, and the OData library will use reflection to read the properties and so on from the classes and build the $metadata endpoint for you. If you have a more elaborate use case where you don't have at compile time all the necessary information and you need to build it at runtime, you can use the explicit builder or the non-conventional modal builder. If you take a look, what you can do is you can build the metadata using code. So maybe you need to read some configuration data at runtime to find out what the service looks like, and then you can use the non-conventional modal builder or the explicit modal builder to write code to generate the metadata on the fly. That's a more advanced scenario. Most OData users don't need that. Most OData use cases are fine with just saying, hey, use the customer class. We saw the customer class up here. Use C# reflection and build the entity data model from the reflection data that you got from this class. Last but not least, you can define your controller and compare to an ASP.NET Core application. The base class is not controller, but it's OData controller. OData controller, if I go here, if we take a look, it's derived from controller base, which you might know from ASP.NET Core. So essentially, we have a superclass of controller base, and this adds the OData functionality. What is the OData functionality? Essentially, you have to use a so-called queryable. What is a queryable? A queryable is a collection in C# that supports queries like filtering, sorting, things like that. And you have to return this queryable and add the enable query attribute. And that's it. As you can see, we have implemented a fully fledged OData service for a single class using 70 lines of code, something like this. Let's try that application and let's see whether it is really an OData service in .NET Core 3.1. Let's run the debugger here. It will spin up my application. Here it is. Debugger comes up. Here we are. It's running. It's listening on port 5000. And if we go here and take a look at my sample request that I created, I can now ask for the metadata. And as you can see it here, we now get our customer metadata with a custom ID, first name and last name. And we can ask for a list of customers, as you can see it here. And we can do all the nice things with filtering and paging and so on, just as you have seen before. So just by providing a little bit of boilerplate code in the startup phase of ASP.NET Core, just by applying or making available a queryable, we will talk about database connected queryable in a second, we can build OData services in .NET Core. What you have to remember when it comes to the new things, use 7.3.0. This one is compatible with .NET Core 3.1. Please remember, endpoint routing is not supported yet. You have to disable it. I've shown you the code, and you can download the code using the links in my slide deck. And the third thing that I would like to point out is the documentation has changed. In the past, the documentation was a little bit awkward, but now the OData documentation with all the details has moved to docs.microsoft.com. So you see, the OData documentation is part of the regular ASP.NET Web API docs, and therefore, it's really convenient to read and convenient to consume. A note here, unfortunately, this is an area where Microsoft could get better. You will see here ASP.NET Core, and you will see that the ASP.NET Core documentation part is really tiny, only a few chapters here. But the good thing is that the ASP.NET Web API documentation up here is equally applicable to ASP.NET Core. So if you don't find the information that you're looking for when you are an ASP.NET Core programmer and you can't find it down here, don't worry, you will find the answers probably here. So you should look into the ASP.NET Web API chapters, and in most cases, you can just copy the code from there. It is just compatible, and most things just work. Okay, let's take a look at a more elaborate feature. How does it look like if you would really like to access a database? Let me show you another sample, but before we stop this debugger session here, and we will close the basic example, and let's take a look at a more elaborate sample. In this case, I'm using Entity Framework with a SQL Server database in the background. Again, the OData related part of this sample is really simple. Most of the code that I'm going to show you here is just related to Entity Framework. Let me quickly open up the data context. You see, it's just an Entity Framework core data context. And just so you see that I'm not cheating, this is .NET Core 3.1. This is 3.1 Entity Framework Core together with OData 7.3. This is now possible. 14 days ago, it became possible. So if we take a look at the implementation, it's regular Entity Framework. What do we have to do if we, for instance, would like to make the customer table through Entity Framework available via OData? It's really simple. The only thing that you have to write is a controller which derives from OData controller. I told you that before. And you can directly return back the DB set from your get method and add the enable query attribute. Of course, using the enable query attributes and additional attributes where you can find the documentation in docs.microsoft.com, you can specify in detail which kind of filtering is possible and so on. You can also do some authorization code here. You could say something like, if something like current user is from Austria, something like this. I don't have authentication in this application. I could say return OK db.customers.where and add something like country ISO code equals .at, something like this. So I can pre-filter the things that I return, and OData will take the pre-filtered result and add the filtering, paging, joining, and so on top of your pre-filtered query. So this is pretty powerful. And how is that possible? Well, it is possible because with Entity Framework, your DB sets, this stuff here, are already iQueryables. So they are immediately compatible with OData. Let me show you how that looks like. let's run this service using the Visual Studio Debugger. Let's give it a second until it comes up. It's starting, looks good. And here again, I have some demo requests. Let's do a simple query querying customers where country ISO code equals AT. AT is for Austria, my home country. And if I click on that, I should get, in a second, here it is, 2 customers. Now, what happened in the background? If I zoom in a little bit here, that's the output of our OData service, you will see that the filter on the country ISO code was really embedded into the query. So the OData query parameter was translated into SQL, and now the database server can do what it's really good at: filtering, sorting, projecting, and things like that. Now, how is that working in the background? It works like that. OData receives the URL from the client. Could be a web client, could be a mobile client, any client that can send an HTTP request. This URL is then parsed by the OData library, by the NuGet package that I showed you before, and the result is a so-called abstract syntax tree representing the query that came from OData. Then this query is translated by the NuGet package that I mentioned into a so-called C# expression tree. If you're not that deep into C#, that's absolutely no problem. Just understand that the C# expression tree is something a little bit similar to SQL, but for C#. And this expression tree is then given to Entity Framework Core, and Entity Framework Core translates it to SQL. This is exactly the query that you have seen here. So this is what's going on behind the scenes. Let me show you a more elaborate sample. For instance, let's take that one here. Customers expand orders. That would be a join. So if we click on that one, we will get the customers and the orders as an array in a single response by specifying this join path. This would be a kind of inner join, but the result is not a flat table like with SQL, but it is a nested JSON response. So very powerful in terms of small result sets, which is important for web applications. And if we take a look again at the query, you see it here, then we see that the join was correctly inserted into the query, and we didn't have to write a single line of code. To be honest, this is what fascinates me with OData. All I have to write is this stuff. Of course, in practice, I have to add a little bit of security, but the core, the essence of the code that I write here is just making the iQueryable available through OData, through the OData NuGet package, and then everything from the URL down to the SQL is done automatically for me. In a similar way, I could do some writing, but I only have 1 hour, so I will not cover it here. And I ask you to take a look in the documentation of Microsoft to understand more details. So this is what Entity Framework looks like. And I have one specific sample built into this example here, because you are data platform geeks, so you are used to writing things like stored procedures and functions to encapsulate complex queries into some kind of programming constructs. And you know what? You can do that in OData too. What you can do in OData is you can specify in your service very complex queries and hide them behind an easy to remember and easy to consume name. So in this case, I added a function ordered bike, and this function ordered bike just returns a list of all customers who have at least one order with at least one order detail where the category code is bike. So give me all customers who have ordered a bike. And if I would like to consume this, it looks like this. OData customers ordered bike. This is very similar to a stored procedure or a stored function. Okay, so if I run this, I will get back the customers who have ordered a bike. And if I take a look at the query that's running behind the scenes, you will see that Entity Framework Core correctly translated this non-trivial query into nested queries, into subqueries, just as we would probably do it by hand too. But the powerful aspect here, that this code still returns an iQueryable. So as the client, I can even add additional filters on top of this query. So I can say something like this: give me all the customers who have ordered a bike, but I'm only interested in customers from Switzerland. If I run that one, I will only get back one customer, because only one customer in my data set has ordered a bike and is from Switzerland. And the powerful thing, if we take a look at the query here, is that we still have the subqueries, but take a look at this code. Where is it? Where is it? Where is it? Bike, and oh, I have to here. Unfortunately, I have a line break here, so I have to enlarge this one. You see, the country ISO code filter was added on top of my action or function. In this case, actions write data, functions typically read data, added on top of my function. And with this, I can encapsulate very complex queries written in C# and still allow the client programmer to specify additional filters, paging, ordering, and so on and so on. And the database will care for doing the heavy lifting and returning the proper results. It can use its index structures and so on to come up to calculate the results in a fast way, in a performant way. What do you do if you want to access such a web API written with OData? If you are in C#, you can use a library which is called Simple OData Client. I will not run this because of time constraints, but let me quickly show you how this code looks like. It looks like, for instance, that one. Give me a list of customers where the filter is country ISO code equals AT, and then I can simply for each over the result. That's it. I can use async await and all the new features of C#, really a nice way. And with the simple OData client, I can decide whether I would like to do it in a type-safe way, you can see it here, or whether I would like to do it, as you can see here, in a more string-based way. If you would like to implement a generic client where you don't understand the C# classes at compile time, you can use this approach. You have the choice, whether you have types or whether you don't have types and you want to do everything dynamically at runtime. This is for C#, simple OData client. If you're not in C#, you can just use any kind of HTTP client that you typically use. For instance, I do a lot of work with Angular, with the Angular framework, and they have an HTTP client. You can use it to access your OData services because at the end of the day, it's really just a RESTful web API. You can use more powerful libraries like Breeze.js, or you can use UI libraries like Kendo UI. Kendo UI is a pretty powerful component library with powerful grids and charts and so on. And guess what? Their data querying platform for data grid, for instance, supports OData out of the box. So you don't need to teach the Telerik grid that there is an OData service. You just can point at the OData service and Telerik immediately understands how to do filtering, how to do sorting, how to do paging, and things like that. So this is another possibility of using a client for your OData. Do we have some drawbacks too? Yes, definitely, unfortunately. First, implementing OData without Entity Framework in the background is rather complicated. You can do it. We have done it in our own product, and you can find samples of dynamic OData services that generate the results at runtime in my GitHub repository, but it's complicated. Imagine that you have a temperature sensor where you want to read data and you want to make it available through OData. That's possible, but it's not that easy. It's not fully compatible with ASP.NET Core 3.1. I mentioned the endpoint routing, and many of the useful tools are legacy. There are tools like client code generators, a framework like Restia. I don't want to describe what it does because it's no longer supported. So if you know OData from the good old .NET framework days, unfortunately, many of the tools that you have been used to in .NET Framework are not available in .NET Core. That brings us to the summary. Yeah, that's good. Time is nearly over and content is also nearly over. It's good if both things come together. So the summary is, OData is great if you have a database in the background and you essentially need a service for CRUD, create, read, update, delete. OData gives the client a lot of control, so you are freeing the client from doing client-side filtering, sorting, and so on. It saves you a lot of development time. It makes you more productive on the server side and on the client side. It's platform independent for the client. That's absolutely true. On the server side, I mentioned, in practice, you are bound to .NET or .NET Core. Documentation could be enhanced, and some pieces of OData smell a little bit like legacy because there are so many tools, useful tools, that are only supported for old versions of Visual Studio and .NET Framework. That's a drawback. It's an open source library. You can contribute. It would be nice if these things would be out there now, available to everybody, but they are not. But it's the basic .NET Core 3.1 support is pretty good, and there is no reason why you can't start using OData with ASP.NET Core 3.1 today. With that, I am done with my content, and I would be happy to answer some of your questions if there are questions. Let me quickly take a look whether we have some questions here, something like here. And let's go to the Q&A panel. Please share the links for slides and code snippets. Definitely, I will immediately do that live, because all I need to do is I need to copy this link here. I'm not that familiar. I will answer it live here. You see slides.com/Rainer Stropek/OData-NET Core. The rest is not relevant for you. This is the URL to the slides, and I will make the slides available also to the organizers so they can share this link. And from that slide deck, you will find all the links to all the samples, and you can navigate it there. What are the kinds of applications that are generally good for considering OData? The kinds of applications that are generally good for OData are CRUD applications, which have databases in the backend where you have ASP.NET Core and Entity Framework. This is really a no-brainer. If you have this combination, for instance, a SQL Server and Entity Framework and ASP.NET Core, OData is really, really nice if you need the client to be in control over what kind of data should be delivered to the client. I hope that answers your question. Why so many REST clients in the community today? Where does the, with so many REST clients, REST Sharp, where does the OData concept stand? I don't have a good answer for that, because OData is by far not so popular as classical REST. Essentially, you can use any kind of REST client as long as it can use HTTP to issue some queries. You send your queries through the URL and you get back some data using JSON. So you don't need a specific REST client. But if you are looking for specific REST clients which also can do intelligent query building like we are used to with SQL and so on, unfortunately, OData isn't that widespread. So the maturity of the clients and the tools isn't where simple RESTful web API clients are. So with OData, you are in a kind of niche. But if this niche fits to your problem, a CRUD service over a database, then it's a very nice niche to be. But don't expect, as I told you, that the tools are as mature as all the other ones. Does OData compatibility with other data sources like Oracle, etc.? Definitely, if you can access the database using Entity Framework or any kind of framework that supports iQueryable, the underlying database doesn't matter. We in our company use it with primarily with SQL Server, but there shouldn't be any problem with OData as long as you have an iQueryable sitting on top of it, and this is typically Entity Framework. I think this was the last question that I currently have open. I will wait for another moment if some questions come in. Otherwise,
there is one question in chat window.
There is a question in the chat window. Let me quickly take a look.
Using OData, will it reduce the time to develop app?
Sorry, I didn't fully get that one. I will open the chat window. I want to open the chat window. Unfortunately, I'm not that familiar with this tool. Can you repeat the question, please?
Using OData, will it reduce the time to develop app?
Using OData, will it reduce the time to develop app? Definitely. Because without OData, let me quickly go back to my slides here, close that one, and go back to this slide here. If you remember that slide here, I told you that in real life, if you develop an app, you have many, many different lists and reports and forms and so on that you need to implement on the client side. If you have a classical RESTful web API, you will end up writing a large number of specific ASP.NET Core controllers with controller methods. With OData, it is reduced to a few lines of code that return iQueryable. And the heavy lifting of translating all the different queries from the client side will be done by OData. So if you have a problem that fits to the area where OData shines, CRUD applications, it definitely can reduce the time writing the application if you are using a relational database, if you're using Entity Framework, and if you're using ASP.NET or ASP.NET Core. This was the slide that I was referring to. Do we have additional questions?
Yeah, one more question.
Can we use OData with .NET Standard applications with .NET Core not being so widely used yet? You can use OData with .NET Framework, classical ASP.NET, and you can use OData with ASP.NET Core. You can implement some pieces of your application with .NET Standard, but when it comes to implementing the web API itself, you have to decide whether you want to go for .NET Framework or .NET Core. Both worlds are possible. So if you are not yet in .NET Core, try to isolate your logic and data structure in a .NET Standard class library, and then use .NET Framework to add the necessary services on top. For instance, in my sample, I did that. As you can see it here, the data model here, this data model, it contains all my data structures and pieces of the business logic is implemented in a class library. And this class library is, as you can see it here, a .NET Standard class library. I hope that answers your question. And I think there are no more questions open. I would like to say thank you for your attention, and thank you for having me. It was a blast. I hope it was interesting for you. And with that, I hand it back to the organizers. Thank you very much.
Thank you, Rainer. Thank you for your time. And all the audience, if you still have any questions, you can use our social channels to post your questions. Here is the Facebook group and LinkedIn group and Telegram channel. All the links are available in chat window. You can join those groups and ask your questions related to today's webinar. And we will get the questions to Rainer and we'll get the questions answered. And as we are talking in the beginning, SQL Maestros is coming up with video courses on SQL Server performance tuning and T-SQL querying and programming, which are based upon master classes and master series. And these video courses contains more than 20 plus expert level modules, which will be constantly updated, and they are advanced and deep dive. There is more than 100 hours of content, which is very comprehensive. And the main advantage of subscribing to video courses is that you can watch the videos anytime, anywhere, and as many times as you can. So if you wish to learn more about SQL Maestros video courses, you can visit sqlmaestros.com, or else you can drop an email to contact@sqlmaestros.com. SQL Maestros also have this hands-on labs, which is a self-paced learning solution, wherein you will be provided with a document which will have step-by-step instructions followed by observations, explanations, and screenshots, so that at the end of each document, you will be able to become expert in that particular topic. So if you wish to learn more about hands-on labs, you can visit sqlmaestros.com. There are more than 100 labs on SQL Server, Azure, Power BI, Analytics, Cosmos DB, and few more related to machine learning and data-related technologies. So visit sqlmaestros.com, or else you can simply drop an email to contact@sqlmaestros.com. So here are the upcoming events of Data Platform Geeks. You can go to dataplatformgeeks.com/events, so that you see all the list of upcoming events and you can register for free. So with this, we are closing today's webinar. Thank you all. Thank you for your time. And we had posted a thank you post about today's webinar on LinkedIn. The link is available in chat window. Please put up your comments there. That will encourage our speakers to come back and deliver free sessions for our community. So link is available in chat window. Please click on the link and post your comments about today's webinar in that LinkedIn post. Thank you all. Thank you for attending, and special thanks to Rainer for your wonderful time. Thank you.